It's a long and time-consuming process, which mostly, as we usually joke, involves I shall potter in with my boiled beef. Right, here we are again, Project Utah. It's been, it must have probably been a few months now since we last did a proper episode on this. Those who follow us on YouTube now will know since then we've been doing these weekly episodes that we call Retro Power Uncut, which is basically a little walk round we do every week just to show what we've been on with that week. So we are still going to do the big project video series, which are sort of shot in a slightly different way, slightly more professional way, let's say. But we're going to make them slightly less frequent, so there's a bigger chunk of progress each time. It just makes probably for a slightly nicer view. If you watch a whole series on one project, you get to see the progress quite quickly. So the last time we looked at this, we were just at the end of metalwork. We were doing all of the kind of mock-up build process of making provision for wiring, plumbing, that sort of thing. I think we just about finished doing all the panel gap work. Shortly after that last video was shot, we would have wheeled this through into our blasting room, blasted the whole shell, and then what we do is we do a sprayed zinc metal spray process on the underside of the body, which we've developed to give a really high level of corrosion resistance. Now that basically entails having the car on a rotisserie, which we do when we blast the shell. Then immediately after blasting, we use a gun that has a solid zinc wire feed into it. It has an oxypropane feed to it and a compressed air feed. And it has a little compressed air turbine that feeds that zinc wire into the gun. The oxypropane flame atomizes it, and then the airflow then sprays molten zinc out of the gun. So you basically got a gun that's spraying molten zinc. It's quite commonly used in construction where hot dip galvanizing is not really an option on big structures like oil rigs and offshore wind turbines, bridges, that sort of thing. And we've been doing this for a few years now, and it's just a really, really good way of protecting the body from corrosion on the underside. So we do that on the whole of the underside of the car, and then also immediately after that we then coat the whole car in epoxy primer. And we do that straight away because just humidity in the air can start to cause surface corrosion on the metal as soon as you've blasted it. So the quicker you get that zinc spray process done and the quicker you seal it all in with epoxy primer, the quicker you've sealed that metal against moisture in the air and stopped any sort of surface corrosion forming. So that's step one. And then of course it would get wheeled through into here, and Gaz would take over to start doing the sort of laborious process of preparing it for paint, which is a long and time-consuming process, which mostly, as we usually joke, involves putting material on and sanding it off again. So initially, once we get it in here and it's all got its epoxy primer on, we'll go around and seal all the seams, and that's done in a way that looks really neat. We basically inject it right into the seams and then wipe off the excess, so it's not kind of got that daubed-on look of kind of factory seam sealer, but all the seams are completely sealed against moisture ingress. And then it's on to good old-fashioned filler work. We've already done all of the lead loading at the metalwork stage, so wherever there's a factory joint along the side of the bonnet, on the pillars at the back there, they were originally lead filled from the factory, and we've done the same process again. And anywhere there's a significant build to do, we use lead, or if it's on the edge of a panel, for instance, maybe on the top of the sill, we'd use lead there because it's very resistant to being chipped off. If you put any sort of normal polyester body filler on the corner of a sill, let's say, it'd be quite prone to getting chipped by a careless seat belt or getting in and out of the car. But there's still an initial filler stage where we pretty much cover a lot of the car in filler and block sand it just to get everything absolutely, glass flat on it. So that initial filler sanding stage, we get that out of the way, and then you'll always find that there's a stage you get to where even with a really hard flat block, you still get a change in the level of surface between where the metal is and where the filler is, simply because the two sand at such a different rate. The filler sands so much easier that you'll always get a slight edge where the transition is. So you then use a sprayable polyester coat over the whole car, which is basically a sprayable filler, but it's what we use instead of any sort of traditional build primer, because the polyester, the two-part polyester, is just so much more stable. So we'll do a coat of that all over, block sand that, so you're block sanding an even surface all over until we're happy that the whole thing is exactly the shape we want it to be. We'll have the doors on at that stage, all the panels on, so we'll literally block across the doors onto the body, down the whole thing with a long block. I mean, one of the blocks we've got is something like this long. It's a yacht building block, but when you're doing long stretches down doors or flat roofs, or relatively flat roofs, I mean, it does curve. It's almost like a windscreen. Well, in fact, if I go over there, out of shot, it's just here. Oh God, everything's going to fall down on you. I got this. There we go, impromptu, but for bigger surfaces, that's one of our blocks, which, as you can see, does curve to conform, but this is a metal bed on it, so you can conform it to a sort of slack radius on the panel, but it will still take out any small variations that you want to lose. So that's the stage we get to with the polyester, and then that really is the final step in terms of actually getting the shape of the car exactly as we want it. At this point, we're only dry sanding everything, because what you don't want to do is trap moisture into that porous material. So the filler and the polyester coat are porous and can hold moisture in. So we seek to avoid wet sanding that. Once we've got to that stage, we'll seal the whole thing in epoxy primer, which again is a non-porous coating, so then it's essentially watertight on the outside. We'll do the underside in a polyurethane coating. We use a branded product, U-POL Raptor, which we've sort of refined our technique for applying it over a few years to get it on really quite smooth. It's still incredibly resistant to stone chipping, but it gives a fairly smooth finish. It's not as smooth and shiny as the outer body, but it doesn't look like a real kind of thick puddingy texture. So we'll do that body coloured on the underside. We do Raptor on the inside as well, although usually if it's going to be upholstered, we'll just use black Raptor. And at that point, the entire shell is sealed in a non-porous coating. So then we'll wet sand that epoxy primer. If you sand dry down to the sort of grade, so we're looking at 800 grit or thereabouts before we put the final paint on, you'll always tend to get some degree of clogging in the paper, and those little tiny clogs of material will then leave score marks in the surface, which you can then see through the final paint finish. So we wet sand the epoxy before final paint to avoid that. And then yeah, once we're at that stage, it's on with the final paint. If you saw the original renderings for the car, it was actually a blue colour. It was Jaguar Opalescent Silver Blue. Now, 1 or 2 episodes ago in the Utah series, I think there was an episode when the owner was here, and we had a discussion at that point. He started to have concerns over the colour choice and whether it was the right decision. He was worried the car essentially was starting to look a little bit too feminine, and he wanted to sort of muscle it up a bit, if you like. And he was talking about maybe doing a green, so we chatted back and forth over various options on the green and did a few spray outs, and I think it eventually came down to a choice between 2, which was a much more modern one, which was a Nissan colour, I forget the name of off the top of my head, something like Millennium Green, which was a colour they use on the Skylines and GTRs. It's quite an unusual one. It's not a very common colour, but it's a nice colour, but it just looked a little bit too modern. And this, which was very similar actually, but just a tiny bit more classic looking, which is Aston Martin California Sage, which I think we were very happy with it when it went on, and then having read comments on social media, I think unanimously it seems to be quite appreciated as a colour choice. So, and certainly the owner came up a couple of weeks back to see the car. I was absolutely over the moon with it, and I think it's going to show off the chrome a bit better as well, being a slightly darker shade. So really happy with the colour choice. We've still got to do the final wet sanding and buffing on it. So this is literally just a from the gun finish, which in all honesty, over most of the car is as good as you'd see on most new cars, but most new cars have a degree of orange peel in the finish, and this has a degree of orange peel in the finish. So the next step, which we always do, is we'll wet sand this with progressively finer grades on hard blocks, and then once we've got to 2000 grit, we'll then move over to machine polishing it with progressively finer grades again to get the final finish. And the idea always is to try and get it completely flat and glossy, and it should look absolutely stunning. So yeah, looking great. A couple of things we did during the paint prep process. We did a fit up of all the trim, so the chrome mouldings that sit down the side, we wanted to be absolutely sure that they all fitted correctly, and we did any tweaks to those that were necessary before final paint went on, just because you feel a little bit less scared when you're offering trims up to an unpainted car. But we wanted it to be fairly well down the prep process, so the shape was exactly the final shape it was going to be. Since finishing paint, we've dynamatted the inside, so that's a sound deadening material that we've used throughout. It's inside the roof as well, all in the lower surfaces there, which will keep some of the road noise out, keep the panels from drumming. It's also a bit of a heat barrier as well, so it keeps some of the heat soak from the exhaust system and the engine minimal. Something else we've been doing is we've had some of the aluminium fabrication done, so the radiator and the fuel tank. The radiator I'll show you. Last time I did actually show you the steel frame. We'd essentially made a mock-up radiator, which we then used to make the mounts in the engine bay. Now, after I showed you this previously, I decided that I wanted to make the top tank of the radiator a specific shape to follow the exact shape of the front panel inside the car. So we sculpted that in just a bit of foam insulation board, glued it on there and sculpted it to the shape that we wanted. And then that was then sent off to Concept Racing, who we entrust our sort of high-end aluminium fabrication work to. We do some ourselves, but when it comes to radiators and fuel tanks, their work is pretty much second to none. So we entrust that work to them. So what I will do is just show you the radiator. I probably scratched the car in the process of doing this. Hopefully not. So as you can see, the engine bay is obviously painted as well. That was an entertaining process because it's such a confined engine bay. It's very, very difficult to lean over and get into the right angles. So when we painted the engine bay, which we did separately to the outside of the car, we actually lifted the front of the car quite high in the booth so that Gaz the painter could actually crawl underneath and pop up in the engine bay, and he actually painted the engine bay from inside the engine bay. Which is all good fun, because obviously when you're doing one side, you've just painted the other side, you've got to make sure you don't touch the wet paint that you've just put on. But really, really happy with how that's all turned out. The radiator, which is here, so this is the radiator which has been fabricated to copy the dummy one that we did. Really nice shaped top tank. They make this in sections. It's welded along the corner here, and before this goes on, it's welded from the inside and then the weld's polished out, so it looks like a formed piece, although there are welds on these corners here. It's got the aircon condenser on the front here, and there's a mount on the side there which is for the aircon dryer. If I just do the very, very scary process of offering this into here without dropping it, you'll see the plan with the top tank shape being that when it's in situ like that, It completely follows the profile of this front panel here, and just looks kind of like a really nice integral part of the design. So I'm actually going to leave that in there because it seems to balance reasonably well. That's tempting fate, isn't it? But it doesn't seem to be going anywhere. So yeah, that's that. And then on the subject of aluminium fabrication, they've also done the fuel tank. So it's probably an opportune moment to have a wander to the back of the car and see what we've been up to there. Okay, so yeah, talking about the aluminium fabrication work. This is the fuel tank. What I will do first is just release the boot so I can show you where that goes. Now, if you remember from the earlier episodes, this boot lid is a handmade boot lid that we made in aluminium, so it's very light and sort of got rid of the number plate plinth that we didn't want on there because we've resighted that down there. So we did the fuel tank mounts up here. The idea being that the fuel tank will sit on here and then there'll be a strap that holds it down over the top. And this is the fuel tank that was made for us also by Concept Racing. We basically sent them a drawing of what we wanted and it was made to our drawing. So we've got the sculpted out sections each side of where the boot hinges sit. That's your filler neck, which connects to the Monza style cap that we've made a recess for on the body. The connections on the top are all going to be vent connections. So we generally have two different types of vent connection. A larger one which goes up to the neck and joins the neck right near the top, so above where your fuel filler nozzle will go when you're filling it with fuel, and that literally vents fuel out above the end of the nozzle when you're filling it with fuel at the petrol station, to avoid the rush of air up the neck, clicking the trigger out and clicking the supply off. And then the other two are vented to air, which allow air into the tank as the fuel is used, or out if on a hot day when the fuel expands. And then we do them on both sides and tee them together so that if the car's parked on a big angle, you've still got one vent not submerged in fuel, whichever way it is. The connection in the middle there, that's for where the fuel sender goes. So there's a tube that drops into there with a float inside it, which is a variable resistor which operates the fuel gauge as the float moves up. And at the bottom there, that is where the fuel feed and return are. So that's the feed to the fuel pump. This is the return back from the fuel rail. And that's a dropped section which is only connected to the rest of the tank via a few small holes. And the idea with that is that this sort of fuel reservoir here stays pretty much completely full regardless of how much sloshing around the fuel is doing when you're accelerating or cornering. And also to assist that, the entire tank is filled with a special open cell foam that the fuel soaks into very easily. But again, it stops the fuel sloshing rapidly around the tank with the motion of the car. So that's that. Just carefully put that down there. Other things on the rear end, the rear lights, obviously we've reshaped most of the rear end of the body from sort of this line down. It's all handmade metalwork. Rear lights, we always plan to have a chrome bezel around these, so we've got some little round LED lights that sit into here, but we wanted to make them look more like they were supposed to be there and look a little bit more classic. I'm wandering over there to get them and I'd already been really organised and put them in the boot, but we had a company called A2P2 here who do 3D scanning and reverse engineering. They've done a few jobs for us in the past. They came and 3D scanned these sections of the body here to then allow them to make a CAD model of a bezel, which we've then 3D printed to do a trial of. So this is the first trial of that bezel. That will sit into there. It's then sandwiched in and held on by the same fasteners that the lamp is held in by. We're completely happy with that. Actually, they've knocked it out of the park on the very first attempt. So they're going to do the other one, and then these drawings will be sent off to have these machined in brass, which we'll have chromed. And we tend to do chrome items in brass just because it chromes really, really nicely. So we'll have these machined in billet brass. And on that subject, we have already done these, which are some little bezel pieces that sit in here. These sandwich in the number plate lights. So there's a modern lamp that we've used, it's actually a Volvo lamp, but it was just exactly the shape that we wanted. That gets sandwiched into there, the little rubber gasket behind it to stop water getting into the lamp, and then these are bolted in, one each side, and they will also be chromed. So there'll be a little chrome bezel around the number plate lights each side. The only other thing I was going to mention at the back end is the wheel arch spats. So these still seem to be dividing opinion. They were part of the original design, and I absolutely still love the look of it with these fitted. Obviously that one's fitted on that side already. Stu handmade these in aluminium, did an absolutely stunning job of them. They're really light as well because the whole lot, including the frame on the back, is all aluminium. Now these fit in a similar way to how the original Jag arches fit, with these two Zeus fasteners which sit into the wheel arch area behind where the door is. So when you open the door you get to these two, and then when the door shuts it covers them up. The rest of the fixings we improved a bit. On the standard Jag, they're essentially just a metal tang that rests on a metal locator on the body, which having a painted metal piece rubbing on another painted metal piece is a recipe for the paint coming off and you ending up with bare steel, which in a wheel arch where there's road muck and salt being thrown up all the time is definitely not a good idea. So we've redesigned those a fair bit. We've got these, the very back one there is a stainless steel plate with a stainless steel locator which is adjustable on it, and then we've milled out these nylon blocks. So that block bolts into the back of the wheel arch. That's bolted to the spats on the studs that are captive on it. So when you fit it in, that slots into that hole on there. And because it's the only interference part of it is between stainless steel and nylon, there's nothing there that's going to corrode or cause any issues with rubbing. And then at the top two sections, there's two additional locators, which are just aluminium tabs with like rubber pads around them. They're anodized to stop them corroding, and the rubber pads sit against the steel body, so there's not really any issue there with rubbing the paint or corrosion on that either. So a nice elegant solution to locating those. That's pretty much covers everything we've done on the shell. We've had various avenues of progress going on elsewhere while we've been doing that. So we'll go and have a look at some of those now, particularly revolving around the mechanical side of things, so axles and engine. Let's go and have a look. Okay, so other bits of the Jag we've been working on whilst the shell's been in progress, with a view to getting it rolling once it's wet sanded and polished, are the axles. So this is the front axle. We mocked it all up on this just in its original state with its sort of slightly rusty used condition. So all of the steel parts on that have now been blasted, zinc metal sprayed and powder coated. All of the parts that have sort of critical mating faces, where you don't want too much powder coat build up on them, have been zinc nickel plated. So things like the actual uprights here, these wishbone mounts, and a few other parts have been zinc nickel plated, all the fasteners as well. And we try and keep the continuity with the colour of fasteners throughout. So even where we've bought new fasteners, the sort of standard bright zinc plating on them tends to not be particularly durable, and you end up with some slightly mixed finishes. So all of the bolts on here, even where they were new, which they largely were, have also been sent away to be stripped and plated with the same zinc nickel plating as everything else. So they have that higher level of corrosion resistance and match cosmetically as well. We've got the brake conversion on here. This is it's an off-the-shelf item that Fosway Performance offer. They're a company not far away from us who specialise in brake conversions and other upgrade parts for classic cars, particularly Jags. So it's aluminium 6-pot caliper. I think they're 305mm discs. I should have done my research there, but if my memory serves me correctly, they're 305mm discs on custom-made aluminium bells, and the calipers mount on these machined aluminium brackets. We've dummy built this all with our 3D printed parts in terms of the steering arms and the rack mounts, and it's a great example actually of why it's worth doing that. We actually held fire on having the steering arms machined, even though we tried them on the car originally and checked all the geometry. If you kind of go back through the Utah episodes, you'll find the one where we were discussing the fact that with the rack and pinion conversion, with the rack in a sensible position versus the cross member, it introduced a lot of problem areas with the geometry in terms of bump steer and Ackerman angle. So we made our own rack mounts and made our own steering arms, and we 3D printed those. Now we held fire on having them machined because we thought, oh, actually the caliper is sandwiched in by the steering arm here. There's a chance that might be very close to either the bracket or the caliper with our upgraded brake package. So we waited for that to arrive, and sure enough, the bracket did foul part of the caliper bracket. So we've done a slight redesign on those. Now we're completely happy with those. They're going to be machined. The rack mounts that are on there we already tested, and they're ready to go away to be machined as well, or the drawings are ready to send off to be machined. They'll be machined in aluminium. The steering arms will be machined in steel. Once we've got those bits back, we're pretty much ready to put all that together. The steering rack's already been rebuilt. Everything else is ready to go on that. The rear axle, we've stripped the casing apart, blasted, zinc metal sprayed and powder coated that. This was already modified previously to have the upper link brackets added. We'll be using a Watts linkage cover. If you remember from the previous episodes, we were running a Watts linkage on this, and we modified the shell to have the mounts for that. This is the diff cover for a 4HA axle that incorporates the Watts linkage mount. Now it's actually a Scimitar cover, because on the Reliance Scimitar they had a variation of the 4HA axle. It wasn't exactly the same width, and it had a different mounting setup on it, but the actual pig's head, as they call it, this piece here, is the same bolt pattern, so the diff cover for those fits straight on in place of the original pressed tin cover. So that's ready to go. We've also been going through lots of other parts and just refurbishing as necessary, so things like all the fasteners for the doors, the latches for the bonnet, boot and door, they've all been stripped apart. Parts are being blasted and zinc plated where they need to be, or chrome plated where they need to be. The pedal box is another example here. We've had this completely apart. The aluminium casting bead blasted. The actual steel pedal arms have all been blasted and repainted or powder coated. And then we've fitted new parts where they've been needed. The servo was tested and is in good working order, so that's been blasted and repainted with a urethane based paint. Put a new seal in for the vacuum hose, obviously new fasteners throughout. So it's just trying to keep things in motion in terms of parts refurbishment while the shell's being worked on. So once the shell's finished, a lot of the rebuild process can happen quite quickly. And that extends to the engine. So we can go through to our engine build room and have a look at that as well. Okay, engine. So you'll just point the obvious thing out first if you've been following this from the start. It's not a Jaguar engine. It's a Toyota 2JZ. We went into the reasons for that choice in probably the first episode. So that in the last episode we talked about the fact that we were going to get a complete short engine, which is the block, crank, rods, pistons all pre-assembled from Toyota new, which we did. That arrived, and that's this. We were also talking about the fact that the head had some damage in one of the combustion chambers. Something had been in it at some point and had been squashed against the squish area of the head by the piston. So there was a little bit of damage on the piston and a little bit of damage on the head. And we were weighing up whether to get this one repaired or whether to try and source another one. And actually it wasn't proving that easy to get another one. So we went with the option of repairing it. So what happened on that was we had the damaged area of that combustion chamber laser welded. We then had just the circular bore part of the combustion chamber on the head remachined to machine down that welded surface back to its original position, which effectively filled the damage and skimmed it back to its original position. And then had the whole of the mating face of the head skimmed, which we would have had done anyway. And then the other parts of the usual process on refurbishing a cylinder head were that we had it all chemically cleaned, and we had the valve seats recut, just to be sure that it's generally a good idea to do anyway on an older engine, but particularly knowing that there'd been some fragments of something flying around in one of the cylinders, there's always a chance that those bits could have been trapped under a valve when it was closing. So just getting the seats recut to make sure that the valves are sealing perfectly is usually a good idea. So we've had that done as well. That then leads on to a job which would have needed looking at anyway, but is pushed into absolute necessity by having the valve seats recut, which is regrinding the valve shims. So on these engines, as with a lot of performance engines, things like the BMW M series engines and most race engines, they're solid cam followers rather than hydraulic ones. So the clearance between the camshaft as the cam comes around and actuates on the follower and opens the valve and then comes back up again, when it's at its furthest away position, there has to be a gap between the two for the oil film to form, so it doesn't just run dry and damage the cam. And on a solid follower engine, you have to set that gap by shims between the valve stem and the underside of the follower. And when you grind all the valve seats, the valves all end up slightly higher up, so you end up reducing that valve clearance to the point where none of them are acceptable sizes. In fact, almost all of them had no clearance whatsoever. So what you have to do is then grind all of the shims smaller to get back to the desired valve clearance. Now, because you can't measure the gap, because all of them are too small, all the shims are too big, so all the clearances are too small, you have to go through a process where you get one shim ground very small, and then try it in all the different ones with it as a known thickness, so there is a gap on every single one, measure what those gaps are, and then from those bits of information you can work out exactly what thickness every valve shim needs to be, and then either have those shims ground, or in our case we're just buying them from Toyota because they still supply all of the different shim thicknesses. So we've got a full set of valve shims coming. As soon as they're here we'll fit those, and that will complete the build of the head. You can see the rocker covers we've now got. These were actually from a company, I can always forget their name, Gulby Parts I think it is, in Australia. I always call them Gulby Customs and then realise I've got that wrong afterwards. So these were actually a pre-existing design that they sell, just a billet CNC machined cam cover set, which is almost exactly what we wanted. So we went with, rather than making our own, we just bought these because we wanted something plain, simple, machined aluminium. We'll anodise these silver, and it's just a nice nod to the original Jag XK6 engine, which basically had two individual polished aluminium covers like that. And then that theme of trying to give it a slightly more vintage, in keeping look with the engine bay is going to extend throughout. So as we've said before, we're using these Genvi Heritage throttle bodies, which are cosmetically a replica of a Weber DCOE carb, but they are actually fuel injection throttle bodies, so the injectors are hidden down inside and they just look like a carburetor, but they're not. The inlet manifold, we designed this. This is just a 3D print mock-up one, which is looking quite battered around now. We've had to glue some of it together because the weight of the throttle body snapped it off. But that's being now machined in aluminium. That'll be just, again, silver machined aluminium, which will have clear anodise, so it'll just be a nice silver polished finish on there. And then we've just been looking at the plug leads. We're making an infill panel, which will just be a laser cut panel that sits down the middle of here. And then the plug leads are going to come through rubber grommets in that panel, and then we're going to have them looping over in pairs. Probably not as high as I just gesticulated then, but they'll loop over in a pair and go down between their matching gap in the throttle body, so they'll come over in 3 pairs. And then on the inlet manifold we've included some little holes in between these ports, which will be tapped out to mount some clips here where the plug leads run through. A little bit of inspiration from the Ford BDA engine for that, and it's only a 4-cylinder, but it has these plug leads that come over in pairs, and it's just quite a nice vintage look the way they come over the cam cover. And then we're going to do them in a braided sleeving, which just is a bit of a nod to the old-fashioned cotton over braided plug leads of the probably 1940s or maybe even earlier than that. So lots of little details to try and keep it looking classic. All the parts I think we've used on the rebuild in terms of the actual engine itself have been genuine Toyota. They supply almost everything still, so it's been great from that point of view. The oil pump, I think we mentioned previously, is now a turbo spec oil pump. The main reason for that being that it has the provision for a crank sensor built into it and the toothed wheel for the crank sensor there, because we've done away with the distributor which normally sits here. And that distributor on the original engine is what provides the ECU with its crank position data, so we need an alternative method, which is what that sensor's for now. So in place of the distributor, we're running a coil pack which is sitting down here. It's just a Bosch 6-cylinder coil pack, and then the plug leads, we're going to get some custom plug leads made, which, as I said, will run over in pairs and come along under here to the coil pack, which is just mounted onto this engine mount down here. We made provision for that when we designed these mounts. And that pretty much covers where we're at with the engine. So the next bits of progress on this will be getting that panel made and the plug leads, which I've just mentioned. There's a little bit of belt train to go together, which I think we're just waiting on some plating. But most of the bits are ready for that. They're on this shelf here. The cam wheels are around somewhere. In fact, they're on the cams over there. We've done the belt covers all in just a crackle black or wrinkle black, whichever you want to call it, finish, so they'll look nice and in keeping. The only bit that's modified on that is this front cover, which normally comes back and integrates into the original cam covers, but actually, because we're using the metal backplate that sits up here as the rear sealing face for the cam belt cover, all we've had to do on this is literally just cut it off shorter than it used to be. We've painted that crackle black as well, and that'll just sit over the front there with the rest of the belt train covered. So we're going to have a fully covered belt train, and hopefully what we think is going to be a fairly classic and in keeping looking, but relatively modern 6-cylinder 3-litre engine, fuel injected, and really looking forward to seeing it in the car. So we'll leave it at that, and hopefully the next Utah episode we do, this will be in the car, so pretty excited about that. I've realised that I constantly say basically or kinda or sorta to like fill in bits. So I'm like, oh, we kind of do this or we kind of do that. I annoy myself. Like, I watch myself back and I'm like, oh, why am I saying this? Just say what it is. Don't say kinda or sorta or basically. Just say what it is. But I can't help it.
That should be a new t-shirt slogan.
Yeah, kinda.
Kinda
Yeah.